So now I would like to invite again representatives from the three projects, but these are different speakers now, panelists now. Mikko Pilati from also VTT Finnish Tech Research Center, Professor Marco Villani from University of L'Aquila in Italy for ReFreeDrive, and Charlie Laneluc from CEA, Commissariat à l'Énergie Atomique in France. And of course, I would also invite our two guest speakers, Philippe van Reel from Avere. And now I have the pleasure to introduce also our project officer from the European Commission, from CINEA, the European Climate Infrastructure and Environment Executive Agency, Michal Klima. So thanks for joining us for the panel discussion. The panelists, please switch in your cameras. And yeah, the three projects have been selected in the call, in the Green Vehicle 04 call into 2017. Next generation electric drivetrains for fully electric vehicles, focusing on high efficiency and low costs. So we had a starting common point when we applied with our three proposals and finally were selected. But not necessarily all the projects focus on each of these elements. So we have a different focus. We have selected different goals. So one was functional system integration, integration of braking systems, lower cost, definitely reduced rare earth magnets, and lower cost manufacturing, the integration of high performance power electronics, and a modular, scalable approach for different use cases. So the first question to our panelists is, on which of these aspects did your project specifically focused on, and why did you choose this aspect among the others? So maybe we can start with the same order. So drive mode, Mikko, I would like to invite you to make a comment on what is the key focus for drive mode, and why did you have chosen this?
Yes, thanks, Thomas. And first of all, thanks all the presenters, and it was great again to see the status and outcomes of each of the projects, and hello to the audience as well. So yes, on drive mode side, we basically, the initial core focus was on the concentrated functional system integration, including the three main elements, which of course the e-motor, the converter, and then the gear, and that having inside the basic choices of the design with the high-speed motor, the wide bandgap semiconductors, and then those leading to the need, of course, of the gear ratio. So this basic design then carries with it the certain, like, downsizing the machine, reduction of the rare earth magnets, and so on. And so there was the functional system integration was the focus, and with that, a key element, as already highlighted by Mernas in the presentation, that we were aiming for a modular design that is then possible to scale and move to different layouts and topologies of the powertrain. So that's also a focus on the modular approach, where the components were from the beginning sought with an analysis of the vehicle market, vehicle sizes, types of vehicles, so that it would be best possible compatibility with the various designs of vehicles of different types, light duty primarily, but we do see potential for also with slight modifications in the design to go to medium duty and even heavy duty. Of course, it's not this power level that we demonstrated in the project would not be sufficient for that. But modularity, scalability for various end use cases. So basically, these were the focused choices, so as to be able to look as wide as possible into the mobility automotive market and which type of various end-use vehicles and platforms.
Yeah, thanks. So very clear. So you're giving a broad end-use range where your model concept could fit. Then I would invite second Marco for ReFreeDrive. What was the key focus of ReFreeDrive?
Thank you, Thomas. Good morning, everyone. The ReFreeDrive project was focused on the design and development of rare-free drives to be proposed as a more sustainable solution for the envisioned growth of the electric vehicle industry. As introduced by Alicia in her presentation, to demonstrate the proposed technologies, we manufactured 8 prototypes of the proposed scalable electric drives with integrated power electronic based on rare-free motor solution. And particularly, you can see in the top, induction motor with the copper cage, die-cast and fabricated rotor, pure synchronous reluctance motor, and permanent mag assistance synchronous reluctance motor. We have satisfied the efficiency and also the hard constraint on the weight. Why? The need for manufacturing with sustainable materials, recyclable and circular, are widely discussed in the European Union, just to mention the Circular Economic Action Plan and the European Raw Material Alliance. And we offer potentially low-cost solutions without critical materials and good life cycle assessment.
Thank you, Marco. Yeah, very nice summary, and also good to remember that ReFreeDrive is comparing 3 different options in the motors, not only choosing one and saying, okay, we can do this, but also giving a comparison to the stakeholder, the academic stakeholder, as well as the industrial stakeholder in this sense. And yeah, then please, I would like to invite Charlie. How did you take the call, the proposal? What was the key focus and for module AD?
Yes, good morning, everyone. Thank you for all your presentations. So for modular electric drivetrains, so module AD, we focused on the system optimization by taking the best compromise of the full powertrain, for example, for the inverter associated with the electric permanent magnet machine, best compromise in terms of technology and topology. The same thing for the reducer. Why did you choose a high-speed electric machine with a reducer, with such a reducer of 2-stage gearbox? And today, the 3 factors which are linking the electric automotive markets are the power density and the power density, the efficiency and the cost. So we want to make efficient powertrain with high power density and at lower cost to be attractive for both manufacturers and buyers. And so for module ED, it was the power density and also the efficiency, and the cost is not today the main thing that was reached, because the GaN technology for the power electronics is still high, and also the injected magnet is a process which is not standardized and costly. But the modularity is for the ease of assembly, for the ease of for the manufacturing, and also in case of failures, if you have to replace an entire system, it's not a sustainable process. So if the system is modular, you can replace the defective pieces, and so it was the aim of module in the whole thing.
Yeah, absolutely. Yeah, many thanks, Charlie. And then also thanks to remember, as your colleague did also in the presentation, so there's still room for improvement for all the 3 projects. So we have not reached the final end of the ideal world. So we can go even beyond. So now I would like to invite, yeah, Michal, if you want to make comment or side questions, feel free.
Yeah, indeed. I think it is clear why the focus of the 3 projects was on increase of efficiency, because when you read the topic description, actually it didn't give much flexibility, as the expected impacts were very technical and quite clear, related either to improvement of efficiencies and for the electric drive, and as well for the powertrain components like power electronics and so on. However, one of the major challenges mentioned as well in the topic description was that in the design of the components, what should be taken in account would be the manufacturing, how the proposal solutions are fit for mass manufacturing. This was not really explicitly addressed by any of the projects, but I think it's an important factor when you go next, when you think about the deployment, about further reduction of cost and so on. So if you could elaborate a little bit how the solution that you have proposed in your projects are fit for manufacturing, and for example, for projects where they have several solutions proposed, which of those you see as the best potential? Thank you.
Okay, thanks, Michael, for this side question. To precise, maybe Mikko, you start. Okay, we all maybe also explain to the audience. So, of course, our project demonstrators are prototypes. So it's a difference if you produce a prototype or if you really go for mass production. But this was also the goal, to show that in theory they could be adapted for mass production. How do you see this, Mikko?
Yes, indeed. It was a research and innovation action, and what we are having at hand at the end is it's not a commercially ready product. And I think the cost element and how it scales up to mass production is a very vital question. And at the end point of Drivemode, we don't have, of course, the full answer to that. There are important industrial partners who then on each of the subcomponent level, of course, will and have taken analysis of the transferability of those into the mass market. But the core innovation is there to reduce the size and the amount of materials used for the components. As such, they do favor this approach, so being more efficient and scaling up efficient production. How the end products would fit if the designs that we had in this phase would finally bring and get to the production industrialization phase, then there are elements which are beyond the scope of what we covered here. And then on the other hand, maybe an element we clearly saw, having the kind of the system IDM, the modular and system approach, there are many aspects which are related to the end user type of vehicle, and those things which are another level of design optimization, which do have a manufacturing and scaling up element in them. Those also, what is the market and how the design needs to be further maybe optimized and designed for the mass manufacture.
And adapted to a specific customer or application.
Sure.
If I may jump in, Drivemode also discuss, just to let's say make it more clear regarding the motor. We use classic production tooling for this motor, so there is no need for some special equipment to produce it. So classic stamping, classic, let's say, winding assembly. So I think by our point of view regarding the motor, it's ready for mass production. We can say that.
Okay, thank you. Marco, how do you see the feasibility for mass production of the ReFreeDrive solutions.
Yes, about our solution, we have focused our attention of the containment of manufacturing cost. Particularly, we have chosen commercial electrical steel, low-cost electrical steel, low thickness, 0.35 millimeter. This is very important respect to thinner material. Moreover, for the manufacturing of the induction motor with the copper cage, the decasting process and fabricated process have been investigated and applied in our project. This is a very interesting solution for this special motor. And also for the induction motor, we have used the high pin technology for the stator winding, thanks to the cooperation with Technomatic company, and that has realized this stator winding that are adopted from several companies. Moreover, we have also checked the manufacturing of the stator and rotor cores, above all for the synchronous reluctance motor, because the synchronous reluctance motor presents an innovative rotor shape. And we have verified with big companies that produce stator and rotor core the feasibility of these rotor cores. And we can confirm that our solution can be realized without any high additional cost and can be used for a large mass production of electric motors. Also for power electronic, we have used a commercial component. We have integrated the power electronic with the motor, and all these solutions are available at reasonable costs.
Thank you, Marco. And finally, Charlie, how do you see the feasibility for mass production of your proposed module ED solution?
Yes, in module ED, there are several industrial companies such as Punch Powertrain and Brusa. Punch Powertrain does, for example, transmission, gearbox, and so they have their online production, and so they are capable today to produce for example, the reducer and gearbox of module ED. So for this part of the powertrain, I think there is no problem to manufacture it at attractive cost, along with the motor by Brusa, so situated in Switzerland. They have their own manufacturer, and they can build such motor. But I would say it's not the case, for example, for power electronics, in which we have used gallium nitride semiconductors technology, which is not the most mature technology in the market. For example, silicon carbide technology is ahead of time compared to gallium nitride for inverters, for automotive application. For example, the partnership between ST and Tesla. So this is why the gallium nitride technology will not be the most used technology for inverter in automotive application. So I think there are some limitations for GaN today to be used in such high current application and high power. But gallium nitride is used for other application, and it challenges silicon or silicon carbide technology, but for lower power application and higher switching frequencies. Concerning cooling circuit, Punch Powertrain does it, and they have a lot of experience in it, and they made the work in partnership with IKA, so an institute based, I think, in Belgium, and they have good thing to do it. And I would like to add also concerning the injected magnet, which is a very innovative process, and brought a lot of good results. It's a process which is quite new, and I think we will need to the world needs to have more insights about this new technology and new thing. I think it's not a viable thing for the automotive market today, and I think that's all I can say about the Modulity project.
Yeah, thanks. And then I think just to add, Charlie, we are in a so fast moving industrial world. So what is maybe not today, in 3, 4, 5 years, who knows? So it could be
I agree with
very,
you.
very fast. Philippe, do you want any final comment on this question, or should we move on?
Actually not. I'm looking forward to the next steps indeed. It's always nice to see the high contribution and the high developed work that has been done in these projects, and also looking forward. Yeah, it should not stop here. So what's the next steps?
Yeah, we're a little bit behind time. So the idea was not to discuss again all these KPIs and the limitations. I mean, all the 3 presentations have provided here the detailed figures, but in the call itself, we had several concrete KPIs: increase torque, power, speed, reduce the motor losses by a half, so going from 92% to 96%, increase the power density in the power electronics as well. And we have achieved, all the projects more or less have achieved these KPIs. So no need to prove these again. So I will turn the question in its opposite. So what was the most challenging? Was it speed? Was it power? Was it power density? Was it cost reduction? Was it and how did you overcome this? And try, I know difficult, but if we can try to make it very, very short, because the third question, I think it's more interesting to the audience. So Mikko, quick, what was the biggest challenge and how did you overcome it?
Thank you, Thomas. Maybe briefly, I think that the technical KPIs and the targets were clear, of course, and very well written, also specific. So I would say that the most challenging part was maybe on the component level, really to meet the double criteria on the e-motor, like having the specific power and specific torque optimized at the same time. And since Damian is online, maybe you want to comment a little bit more on that briefly. But so maybe that's the one design aspect that we were discussing and analyzing the most. And maybe then the second I want to lift this is the cost element and scaling up. I touched upon that already earlier. I think it's easier then to go do the cost analysis on sub-component level, like for the inverter, the e-machine and the transmission. But then as the approach was the modular powertrain element as a whole, so then the cost should be, that's the relevant, technologically relevant item and unit that we want to apply in the automotive. So we should be analyzing the cost elements of the modular entity, and that brings a lot of new variables then in terms of the design and how, and also the design frame and design basis for which application and vehicle. So that line of discussion already touched makes the cost analysis then much more complicated. But yeah, Damian, if you want to jump in briefly on in the e-motor, torque versus power.
Okay, thanks. Let's say we set some boundary conditions at the beginning. That means not to increase too much, let's say, the inverter size. So one of the limitation was the RMS current of the inverter, and not to go, let's say, to break it, to burn it. So we have a limitation. Upper limitation was the current. That means that we were somehow limited by the torque. So by the call, it was written there also that we have to increase the specific power density and also to increase the speed. And that goes very good together. So we increase the speed and then increase the power, as well increase the battery voltage. Nice to have with silicon carbide But on the other side, we put ourselves the limitation of the highest, let's say, allowable current. That means that our, let's say, our torque was limited by the current, which was set by ourselves to meet the vehicle performance. So let's say if we a little bit increase the size of the inverter, then we can also increase the power, the torque density. So it's a boundary we set by ourselves. It's because, okay, it's written torque density and power density, but physically it's very, let's say, difficult to achieve both densities at the same time regarding the boundary of the, let's say, other surrounding components. I hope I explained to.
Yeah, so typical trade-offs we have to make a choice and focus on one. Marco, what was?
Okay.
Sorry. Thanks, Damien. Marco, what was most challenging in ReFreeDrive?
Yes, about ReFreeDrive, the project was quite challenging since our Refree solution present deep research and development concepts, and several KPI was selected as target, starting from the Tesla Model S16 and including requirement from the partner Jaguar Land Rover to match the vehicle integration boundaries and the market expectancies. One of the main technical challenge was to increase the rotational speed without affecting the rotor mechanical integrity. We did several mechanical analyses to reduce the risk of rotor failures at high speed. Another challenging aspect was related to the trade-off between scalability and manufacturing processes. For instance, we select two different operating voltage for the 75 kilowatt motor and 200 kilowatt application. The two different voltage were 350 volts and 750 volts. To maintain as much as possible the same manufacturing process for the stator and rotor cores, winding layout and copper rotor for the different power sizes. In this way, even if the motor have been optimized for the higher power rating, acceptable performance has been obtained down to the 75 kilowatt versions.
Thanks, Marco. Finally, Charlie, what was most challenging in module ADE?
I think they were all challenging, but if I have to make a classment of this, I would say that the torque required by the project was very high compared to the technology used with low current capability for the power electronic side. So this is why we made some choices, for example, to use an exotic topology instead of classic topology of inverters, which can reduce the constraints on the current, keeping the same output power, but leading to lower power density. But so it was all along the project a compromise between power density, cost, and efficiency. They were all difficult factors to fulfill, but during the project we worked well, and concerning the efficiency, we reached a really high efficiency, for example, for the electric machines, the gearbox, the reducer, and the power electronics. Concerning the costs, I would say that still GaN will not be the technology to use because it will be too costly, and also in terms of reliability, it does not reach the level of silicon or silicon carbide technology. It was also very difficult during the project to get the right devices, for example, due to some penuries through the project, for example, for power electronics. So for example, we had to go to some conferences to go to manufacturer and to ask them to get the component to fulfill the modularity project. So it was quite hard to do that. But in the end, we fulfilled the power requested by the project, not the torque. That's to say, we are not going from 0 to 100 km/h in, for example, 3, 4, 5 seconds, but in the acceleration is lower, so maybe in 7, 8 seconds. But I think it's not the matter of the project. The idea was to fulfill the output power and not for sure the acceleration. And concerning the cost today, I would say it's a big question, especially concerning the power electronics, which is very costly. But concerning the electric machines, the reducer and gearbox, it's manufacturable. I would say power electronics is more complicated, and I do not have all the inputs to answer this question.
Okay, thanks, Charlie. Definitely good to point out. Michael, this call put quite challenges to all the 3 projects. I think all the 3 projects have struggled but have managed. Any quick comment from your side on KPIs, or because the next question will be interesting.
Yes. I don't want to elaborate on all the particular one. I think there was already enough. My question would be more general, and the question would be similar like in the technology of internal combustion engine. We have got into the situation where we cannot improve significantly unless introducing very expensive solutions like after treatment. And even though there are the physical rules that prevent, for example, the zero emission. Now we are in the electrified drives with electric motors. With the efficiency very high, I mean, we speak about 90+%. The same applies for power electronics. And the contradictory movements are the increase of cost and maybe the complexity of manufacturing, and maybe as well issues related to safety, reliability, and so on. So my question would be, what do you see as the future? What is still the potential to improve? In which areas does it actually make sense to move the technologies higher? Are there benefits? So what is your view on this?
Yeah, interesting question. Mikko, what is the future?
Thanks, Michael. I think it's an essential question. And what we had a final meeting yesterday, and basically what the project group and partners concluded that we would have tremendous potential to optimize it further, to take it further. We have many ideas, really, and it would be only now that we would start to see, and maybe most of those elements would be then linked to an automotive and application and so on, having at the same time still potential in each of the components. And the next phase would be to really go up in the TRL and take the manufacturing scalability aspects, the modularity into analysis in detail. But definitely we believe these technological choices that we made and also the approaches do have future. And we were really happy to see our demo vehicle really placing not too far from the BMW i3 in terms of energy consumption in the WLTP. But still, we thought that it could be much improved. So I think there's potential.
Marco, how do you see the future
For
improvements?
For this question, I leave the floor to my colleague, Dr. Giuseppe Fabri. Do you see? Okay. A moment.
Yes, good morning to everybody. Yes, interesting question. We have seen a lot of challenges in our project developments, and for the future, it will be interesting to to check a bit more in deep our motor technologies. For instance, we was in our case we was expert in designing of synchronous reluctance machines for industrial application. But when we started to design it for automotive application, a lot of potentialities arises in this kind of design. So, in my opinion, we are. We are just at the beginning of the story, because we are now introducing these new powertrains for electric vehicles, and there is a lot of margins in R&D activities in the fields, both with the motor, with the power electronics, and new materials and technologies will for sure enhance the performance and efficiency of this kind of devices. We had contact with several stakeholders during the projects, and we designed with standard material and technologies available in the markets. So our design was ready for mass production, but talking with the stakeholders, we had a lot of input to improve our designs, our performances with brand new, for instance, electrical steels and also process for manufacturing to enhance the mechanical speed of the rotor as example, and other figures. And just to mention that one of our papers, we also investigated new cooling technologies with nanoparticles in the cooling fluid. This is also one interesting point to develop. And that's all. Thank you from my side, I think. We lost Thomas.
Okay, it seems like we've lost that. So mainly, Charlie, maybe you have something to say as well, or to reply?
Yes, it's a difficult question, Michel. I'll try to answer it. I think today a big step has been crossed because with previous automotive electric automotive vehicles, for example, the efficiency was between 75 and 85, and today we reach overall efficiency, including batteries, power electronics, and electric machines, reducer close to 90%. So it's a big step crossed today, and it has to be, especially with the growth of electric vehicle in the whole world. But I think there is the manufacturability to take into account, and the profitability for the industrial to make the car. There is a compromise between having new technology in a powertrain, high efficient, but also at higher cost. So it has to be profitable for manufacturer and to sell them to buyers, and to be at low cost for buyers, and to be affordable. So I think today the powertrain made by Refree Drive, Drivemode, and Modulity is from tremendous works with very high technologies, but still at high cost. So there is a compromise between extra technology in the powertrain, high efficiency, and profitability for industrials, and the selling for particular to be attractive.
Okay, thank you. So I think probably we have lost the moderator, I think. But nevertheless, I think we can continue, because I still have one question, which is for all of you. And this is related to future potential for exploitation, for industrialization, and what in your view would be a support needed? I think we have a big gap that we have in the support of research and innovation activities, which are really funded 100%. And then if you go to bank loans, and this is a completely different environment, there you have to have a business plan. And so one thing is what for your particular projects, what you foresee as a potential exploitation potential. And the second part, if you can reply as well, what kind of support you think you would still need to get there, to get a final industrial product that we could see in future, maybe on road? So maybe Mikko, if you could reply first.
Okay, thanks, Michael. Basically, of course, the industrialization question should properly be answered by the industrial partners. But we did have quite an extensive discussion on exploitation strategy while carrying the IPR and the innovations that we produced within the project Drivemode along the line. What we came up in the end was basically the exploitation strategy following the path of each of the subcomponents and the companies themselves. So we have, for example, for the e-motor, we had C&E drives and AVL, which are already in further analyzing the approach and the potential for further exploiting these innovations in their product lines, in the offerings towards their business-to-business customers. In the same way, we have Semicron, basically, who are bringing the core semiconductor technology that we applied, and then Danfoss, who was more on the control software of the inverters side. So both of them, the actual strategy will be adopted by the companies themselves, and I cannot speak for that. But for sure, there are elements and sections of the market and the emerging opportunities that seems that each of the companies will follow in their own, as part of their own strategy. Further on.
Yes, sorry, a major GAU, so I had a short circuit here at home, so no electricity, and the router had to reboot. So, but I think Michael, you moved already to the third questions and jumped in as a moderator.
Yeah. So the reply was already from Mikko, so we still have Marco and Charlie to complete.
Okay.
Yeah, thank you, Michael. Okay, Marco, then exploitation.
Yes, I'll take this question. And for the life of the project, we pushed out the dissemination campaign in attempting to reach as many stakeholders as possible to propose our motor technologies. A bit differently from the other project, our project was mainly focused on the motor research part. So our final prototypes presents a TRL less performant with respect to the other projects. So it was, let's say, difficult to propose the project for the direct application in vehicle. But nevertheless, many stakeholders was interested in the fact that the motor are actually rare earth free. And one of the difficulty in the exploitation is that, of course, stakeholders meetings are confidential, but we designed for JLR. JLR is investigating deeply these technologies, but when you discuss with other OEMs, they have their own requirements. So it means that the machines needs to be re-engineered for the wall. And this was the aspect that limits a bit our project in seeing it on road, let's say. Nevertheless, the know-how developed in our project was very high, And we wrote a lot of papers on our design methods, and the know-how belongs to all the partners. All the partners wrote a lot in the technical aspects, also because a lot of prototypes has been manufactured, up to 8 prototypes. So this gives rooms for many exploitation of the know-how acquired during this project. And we also need to think about that today maybe rare earth machines has better potential in terms of efficiency, and OEMs are looking to that to decrease the battery costs. But in the next future, when the battery costs will decrease, more circular and cost-effective solution on the motor side could attract more attention by the manufacturer.
Yeah, thanks, Giuseppe. And Charlie, how do you see the exploitation avenues for module ED?
Yes, we made a lot of researches about the exploitation plan and dissemination. So, in fact, we have 2 big industrial companies in our consortium, and they are able to build their own electric machine transmission gearbox. And for CA, as we are a large research institute in France, we looked for manufacturers capable of taking again the new technology and making it a new industrial product. So it's a thing that is it's difficult because of the new technology and the high cost. And this is not clear today that GaN could be integrated in an electric automotive vehicle, but we are trying to lead. This is the role of such research institute to guide new industrial to other technologies and to show them their performance and what they can gain from it. So this is still a thing which is ongoing. Yeah.
Thanks, Charlie. Before I give you the final floor, Michael, for the final last words and your wrap up, the opportunity to anybody else here, Philippe, Alicia, Wouter, Mernats, do you want to add any comments or? Well, then if not, then Michal, the floor is yours. Thanks for your final words and your takeaways here.
Okay, thank you very much.
First of all, thank you for having with us more than 3 years, 3.5 years. You've been the only project officer. You've stayed with all us. You gave us very good, constructive critics and direction. So thanks for being our project officer.
Okay, well, thank you very much for these kind words. As well, I would like to thank you to all presenters. I think it was quite interesting and comprehensive, showing all the objectives of the project, but as well the challenges and the results. Also, I would like to thank you to all the participants today. At the peak, I think we did have more than 260 people interested in the results of these projects. Just a small recap. So these 3 projects were funded from the European Horizon 2020 program, specifically from the 2017 Green Vehicle Work Program. And the major objectives of the Green Vehicle Work Program were to bring improvements in the energy efficiency of the road transport vehicles, and as well to support non-conventional energy use. At the time of that, the non-conventional energy were considered to be as well alternative fuels and so on. But we see that on the path to the transition towards the zero emission, the electrification is possibly the most viable solution. And from that point of view, the objectives of the call and of the topic, and as well the results of these 3 projects still contribute to the challenges as they are now for the Green Deal, for the decarbonization, and for zero emission mobility. We have financed 3 different projects from the same topic, and it was not a coincidence that they are very complementary and as well a little bit different in terms of the objectives that they were addressing. We have the Drivemode, which was focusing on the modularity of the concept, with some challenges related to this approach. We have the Refree Drive with focus on the different configuration of the electric motors. I think with the induction machine with copper rotor with 2 different variants, synchronous reluctant machines as well with 2 different variants, and as well with the different powers. And finally, with the complement of the module ED, where FD as well have developed a new permanent magnet synchronous motor. But in addition to these predecessing 2 projects, as well a new power electronic inverter based on new gallium nitride technology, with some pros and contras for each particular solution. So from that point of view, we didn't have significant redundancies, and we have a very complementary research. And now I think in terms of results, we know what are the potentials and what are the potential further paths in this research. Also, thanks to the fact that there were 3 projects from the beginning, we encourage the cooperation of the projects from the beginning. So they met together already at the first meeting we did have back in INEA at when the start of the grant agreement preparation. And since then, they did have the opportunity to meet, to discuss, and to find potential synergies in terms of communication of the results. This is not the first event that they made together, but as well, I think not only in terms of communication dissemination, but as well in terms of enriching the knowledge about the area, about the challenges that they have, and maybe as well trying to find solutions together. So this is very important. I said already this was a very challenging topic. It was a research and innovation action. So with starting somehow low TRL levels, with starting with the design of motors and of power electronics. But one of the requirements was to have as well working demonstrators. And at the end, even though the final conference is only virtual one, we saw on pictures even a vehicle on road. So there was a long path starting from the first initial design of the components up to the integration into the vehicle and demonstration. And this was all under difficult circumstances, although it was not so much mentioned today. There was an influence of COVID pandemic, and these projects were just hit very in a critical phase when the laboratory research and desk research was finished, and they needed to go to the integration of the components and into the workshops. And this was just happening at a time when the pandemic was just starting in March. So all of them were affected quite high, and this resulted into some delays and into prolongation of the projects. But now we are at the end, and all of them were able to finish with the prolongation on time. And I think we can be very proud of the results. Just outlined a little bit future. So this, as I have mentioned, were projects funded from the Horizon 2020 work program. This is over because this ended in year 2020. And now we are in the new future, which will be Horizon Europe. The Horizon Europe started in 2021, but for the area of the road transport, the first work program will be published quite soon. I hope it will be happening by the end of April or maybe early in May. And what I can say, since it is still not yet official work program released, is that the first deadline we can expect after the summer, if everything goes well. And I am sure that the area of electrified powertrain about the further optimization of the powertrain components. And as we've heard in the discussion today before, there is still room for improvement, and there is still need for research, that these topics will be still included in the work program. So I think I can only encourage our stakeholders to look out for the new work program and to look for the new funding opportunities. By this, I would like to conclude. Again, I would like to thank you to organizers of the event, as it was well running. I would like to thank again to all presenters today, and I wish you good luck and good luck with further exploitation of the results of your projects. So have a nice day and goodbye.
Thanks a lot, Michal, for these nice final warm words, and also for outlining the Horizon Europe program as an opportunity, as a new playground for further improvement. So we're just, I think, at the beginning of a very interesting time frame in Europe, going towards green, sustainable and circular economy, and to reach our targets to ultimately reduce CO2 wherever we can, although it must be cost effective, of course. So also from my side, thanks to all representatives of the 3 projects, Drivemode, ReFreeDrive, and Module ED. Thanks to Philippe from Avere. Thanks to Michal again. And as we mentioned in the chat, to the audience, of course, we will have public available presentations from the projects, and we will share this with the stakeholder audience.
Very good. So thank you very much. I will simply intervene here to adjourn today's session. Thanks to our audience, we had almost 500 registrations indeed, and participation of more than half of these people having registered. So it looks like there is strong interest in e-mobility, and more particularly on the technological solutions developed in these projects. And stay in touch for future work. Thank you very much, everybody.
Okay.
Thank you. Bye-bye.
Thank you.
Thank you.
Bye-bye.
Goodbye.
Bye-bye.
Bye.